Welcome back, my dear students. Today I am going to start a new reagent, which is Sodium Boro Hydride NaBH4. As you know, it's a better reducing agent as compared to lithium aluminum hydride. It is a weak reducing agent. So first role of sodium borohydride is it reduces carbonyl compound and acid chloride to alcohol. So for example, if you take CS3CO, CS2, CS2, COO, C2H5. As this compound contains both carbonyl group as well as C double bond O single bond O ester group. So in presence of NaBH4, the ketone group is converted into alcohol and ester group remains as it is. It does not reduce into alcohol. So you will get CS3CHOH, CS2, CS2, COO, C2H5. Second reaction you can consider C6H5CO, CS2, CS2, COH. As it contains ketone group as well as carboxylic acid, so in this case sodium borohydride, it reduces C6H5CHOH, CS2, CS2, COH. So this COH group, that is carboxylic acid, remains as it is. Next one, if you take two carbonyl group containing compound, that is CS3CO, CS2, CS2, CO, CS3, in presence of NaBH4, it gives CS3, CHOH, CS2, CS2, CHOH, CS3. So both the carbonyl group is converted into alcohol group. Next one, if you take CS3OH, CHOH 4 times CHO, in presence of NaBH4, so you will get CS2OH, CHOH 4 times CS2OH. So alcohol group remains as it is and aldehyde group is converted into alcohol. Next one, if you take C6H5CH double bond CH CHO, so it gives C6H5CH double bond CH CS2OH. So in this case double bond remains as it is. It doesn't reduce into alkane, so it remains as it is. Double bond remains double bond in case of product as well, and aldehyde group is converted into alcohol. Next one, if you take CN, CS2, CS2, CHO, in presence of NaBH4, it is converted into CN, CS2, CS2, CS2OH. So CN group, cyanide group remains as it is, and aldehyde group is converted into alcohol. So what we have seen in this particular reaction, you will find the strength of NaBH4 is not as powerful as lithium aluminum hydride, so it reduces only a specific group. For example, next one, if you take RCOCl in presence of NaBH4, it gives RCS2OH. Next, if you take benzene ring and diagonally opposite, if it is NO2 group and CHO group, that is para nitrobenzaldehyde in presence of NaBH4, NO2 group remains as it is. It doesn't reduce, but the aldehyde group is converted into alcohol group. So you will get NO2 group and diagonally opposite it is CS2OH, or you can say it is para nitrobenzyl alcohol. The next one we will consider in presence of R2 C double bond O, that is ketone, plus NH2 NHTS, that is para toluene sulfonyl hydrazine, in presence of NaBH4. Finally it gives R2CH2. So in intermediate stage it forms R2 C double bond N bond NHTS. Next one, if we take the ozonite group, that is reduction of ozonite. So if you take cyclohexene upon ozonolysis, you will get the 4 carbon in the ring form, and the first and 6th carbon is attached with ozone, which on reduction with NaBH4 it gives hexane 1,6-diol. So CS2OH, CS2, 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 CS2OH. Next one, reductive alkylation of amines. So if you take ketone RC double bond OR plus R dash NH2 in presence of NaBH4, it forms RCOH NHR bond, and one bond is satisfied with alkyl group. On hydrolysis reaction, it gives RCR, and the one valence is satisfied with NHR dash, and the central carbon is attached with one more hydrogen atom. So sodium boro hydride is highly specific reducing agent. In your competitive exam, you will find out one of the problem may be or must be related to NaBH4, because it is highly specific reducing agent, and it reduces a few group if more than one functional group is present in a compound. Next one is reduction of carbon nitrogen double bond. If you take C double bond N containing compound in presence of NaBH4, so double bond is converted into single bond, and hydrogen is attached with both carbon and nitrogen atom. Next, if you take ester group, so on reduction in presence of NaBH4, ordinarily ester group are unaffected by NaBH4 ordinarily, but in the presence of LiCl or AlCl3, in presence of diazyme, that is diethylene glycol dimethyl ether, they are reduced to alcohol. So what we have seen earlier, if it is RC double bond O single bond OR, if it is ester, only in presence of NaBH4 it doesn't get reduced, but in presence of LiCl in diazylmine, that is DIGLYME, the full form is diethylene glycol dimethyl ether, so you will get RCS2OH and R-OH. So we will get 2 different alcohol. So it is highly specific reducing agent. Next one, hydration of olefins. So if you take CS3 CS2 C double bond CS3 CS2 in presence of Hg OAC whole twice in presence of NaBH4, it gives CS3 CS2 C CS3 CS3 OH. Next one, preparation of Diborane. So if you take BF3 plus NaBH4, so you will get B2H6 plus NaBF4. Hydroboration is done in situ, SiTu, either in presence of tetrahydrofluoride or in diglyamine. So if you take BF3 plus NaBH4 plus RCS double bond CS2, so you will get RCS2 CS2 whole thrice B plus NaBF4. And the last reaction we will consider in case of NaBH4, in presence of benzene diazonium salt. If you take C6H5 and 2Cl in presence of HBF4, it forms C6H5 and 2BF4. So you can take N2 plus and BF4 minus. So when it reacts with NaBH4 in presence of CS3OH, so you will get benzene. Benzene will be the final product. So in this particular reaction, what we will consider, so in this particular reaction we have considered 9 different type of reaction, which is highly useful. It is very important for your competitive exam. So that's why I have considered only NaBH4 in this particular video, and in the next video, in the next lecture, I will provide you the role of oxidizing agent. The most important is KMnO4. So the next video is very important for your competitive exam. So far we have discussed 5 different reagents. I have already completed reducing agent. So now in the next video I will provide you the most important reactions and the role of KMnO4 and other oxidizing agent. Thank you, and please subscribe, so it motivates me to provide you more and more information which will be useful for your competitive exams. Thanks a lot.